Hi everyone, welcome to my channel. In this video, I'm going to explain some important formulas for the subject Basic Circuit Analysis for Unit 1 Introduction to Electrical Circuits. The first formula is voltage. Voltage is defined as the work done by the charge. The formula is V is equal to dW by dQ. The unit for voltage is volts. Next, current. So current is defined as the rate of flow of charge or the flow of electrons. Therefore, it is given as I is equal to dq by dt, and the unit for current is amperes. Next, the formula for power is dw by dt. So the rate of work done. So this power is called as physical power, whereas P is equal to VI. So this power is called as electrical power. So the unit for power is watts or kilowatts. Next, Ohm's law. So Ohm's law statement is at constant temperature, current flowing through the conductor is directly proportional to potential difference across the conductor terminals. Therefore, V is equal to IR is the conclusion for Ohm's law. Next, resistance. So from Ohm's law, we can write R is equal to V by I, or the physical resistance can be measured as R is equal to rho L by A, where rho is called as resistivity, L is called as length of the conductor, A is called as area of cross section of the conductor. The unit for resistance is ohms. Next, the power dissipated across resistor is P is equal to VI. From V is equal to IR, if you substitute this, you will get I square R, or I is equal to V by R. If you substitute that, you will get V square by R. So next, energy across resistor E is given as E is equal to the energy nothing but power into time. Therefore, V into I into T, or I square R T, or V square by R into T. So the unit for energy is joules. Next, if n number of resistors are in series, the equivalent resistance can be given as R equivalent is equal to R1 plus R2 plus R3 and so on Rn. Similarly, if n number of resistors are in parallel, the equivalent resistance is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus and so on 1 by Rn. Similarly, if only two resistors are in parallel, the short formula is R equivalent is equal to R1 R2 by R1 plus R2. So next, the formula for conductance is G is equal to 1 by R. That means the reciprocal of resistance is called as conductance. Its units are mho or Siemens. Next, if alpha is the temperature coefficient and R naught is the resistance at 0 degrees centigrade, then the resistance at T degrees centigrade is given as RT is equal to R naught into 1 plus alpha T, where RT is nothing but the resistance at T degrees, R naught is the resistance at 0 degrees, alpha is the temperature coefficient. Next, the resistivity or specific resistance at T degree centigrade is given as rho T is equal to rho naught into 1 plus alpha T, because resistance is directly proportional to resistivity. That is the formula. That's why we are getting this relation. Next, Faraday's laws of electromagnetic induction principle. So from this principle, we are getting the conclusion as V is equal to N d phi by dt. So next, Lenz's law is given as V is equal to minus N into d phi by dt. Next, the voltage across inductor is given as V is equal to L di by dt. Next, current through the inductor is I is equal to 1 by L integration V dt. Next, energy stored by inductor is E is equal to half Li square joules. So it's a very important relation. Next, physical measurement of inductance can be given as L is equal to mu N square A by L. This is also a very important relation, where mu is called as permeability of the medium, that is given as mu naught into mu R, where mu naught is called as permeability of free space, that can be given as 4 pi into 10 to the power of minus 7 Henry per meter. Where mu R is called as relative permeability, its value is 1 for air or vacuum. N is nothing but number of turns of the coil, A is nothing but area of cross section of the conductor in meter square, and L is the length of the conductor. Similarly, if n number of inductors are in series, the equivalent inductance is L equivalent is equal to L1 plus L2 plus and so on Ln. Next, if n number of inductors are in parallel, the equivalent inductance is 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus and so on 1 by Ln. If only two inductors are in parallel, then the equivalent inductance can be given as L equivalent is equal to L1 L2 by L1 plus L2. Next, the self-inductance of coil 1 is given as L1 is equal to N1 by I1, where N1 is the number of turns of the coil 1, Phi1 is the flux produced in the coil 1, I1 is the current flowing in the coil 1. Similarly, you can also write self-inductance of coil 2 as L2 is equal to N2 Phi2 by I2. Next, mutual inductance of coil 2 due to current in the coil 1. So that is specified as M12, where 12 and 1 stands for the current in the coil 1, 2 stands for the flux in the coil 2. Therefore, M12 is equal to N2 Phi12 by I1. Similarly, mutual inductance of coil 1 due to current in the coil 2 is M21. So where M21, 21 stands for, 2 stands for the current in the coil 2, 1 stands for the flux in the coil 1. Therefore, M21 is given as N1 Phi21 by I2. Next, the mutual inductance of the two coils can be given as M is equal to K into root L1 L2, where K is nothing is called as coefficient of coupling. L1 L2 are the self-inductances of the coils 1 and 2 respectively. Next, coefficient of coupling is given as K is equal to M by root over L1 L2. The unit for self-inductance and mutual inductance is same, that is Henrys. Next, if the mutual coupling is there, that means by the dot convention principle, we can write the equivalent inductance under the influence of mutual inductance is given as a series aiding case L equivalent is equal to L1 plus L2 plus 2M. That means here the dots are in the figure A, the dots are placed at the current entering terminal, whereas the dots are placed in the figure B at the current leaving position. So these two cases are called as series aiding case. Therefore, the equivalent inductance, the mutual inductance in the two cases is additive. Therefore, L1 plus L2 plus 2M. Similarly, series opposing case, for coil 1, the dot is placed at the current leaving position, whereas for coil 2, the dot is placed at the current starting position. So, and vice versa, the figures are showing C and D. So, this case is called as series opposing. So, such case, the mutual inductance is opposing, so negative sign. Therefore, the equivalent inductance is L equivalent is equal to L1 plus L2 minus 2M. Similarly, parallel aiding. So, if the two coils are connected in parallel, so in the same case, if the current is entering in the same positions, either starting or leaving position as shown in the figures A and B, so this case is called as parallel aiding, and the equivalent inductance is L1 L2 minus M square by L1 plus L2 minus 2M. Similarly, parallel opposing, for one coil, the dot is placed at the current starting position, and the other for the other coil, the dot is placed at the current leaving position, and vice versa, the figure showing C and D respectively. So the equivalent, this case is called as a parallel opposing, and the equivalent inductance is given as L1 L2 minus M square by L1 plus L2 plus 2M. Next, the capacitance is given as charge by voltage, C equal to Q by V. So the unit for capacitance is Farad. Next, the voltage across capacitor is given as V is equal to 1 by C integration I dt. Next, current in the capacitor is I is equal to C into dV by dt. Next, energy stored by capacitor is half CV square joules. This is also very important. Next, physical measurement of capacitance is given as C is equal to epsilon A by D, where epsilon is called as permittivity of the medium, that is given as epsilon naught into epsilon R, where epsilon R naught is called as absolute permittivity, which value is 8.854 10 to the power of minus 12 farad per meter. Epsilon R is nothing but relative permittivity, its value is 1 for free space or air or vacuum. A is nothing but area of each plate, because capacitor is a parallel plate combination separated by some dielectric medium. That's why A is nothing but area of each plate. D is the distance between the two parallel plates. Next, if a number of capacitors are in series, the equivalent capacitance is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 and so on 1 by Cn. If two capacitors are in series, then the C equivalent is given as C equivalent is equal to C1 C2 by C1 plus C2. If n number of capacitors are in parallel, then C equivalent is C1 plus C2 plus and so on Cn. Next, voltage division rule. It is used to find the unknown branch voltage in the given series network. Therefore, it is given as Vx, nothing but unknown voltage across a resistor. That is given as the total voltage, that is supply voltage, is multiplied with its own branch resistance by total resistance. Next, current division rule. It is used to find the unknown branch current in the parallel network. So therefore, it is given as a direct formula, that is shortcut formula, Ix, nothing but unknown branch current in the parallel circuit, that is given as total current multiplied with opposite branch resistance by total resistance. Next, so delta to star conversion. So if you know the values of delta values, it is possible to find out the equivalent star values by using the formulas R1, R2, R3, where R1, R2, R3 the unknown star values, unknown star resistances, whereas R12, R23, R31 are the known delta resistances. So by using these three formulas, we can calculate the unknown star values. Similarly, star to delta conversion, if you know the star values, then it is easy to find the delta values by using the three formulas R12, R23, R31. So here it is very easy to remember these formulas. For example, take R1. So here 1 is the suffix. So this suffix should be there in the 3-1 and 1-2. And the denominator will be common for every formula. So similarly R2, 2 is a suffix here, therefore this will be present in the R23 and R12. So the numerator will contain R23 and R12. Next R3, here the suffix is 3. So among the 3, R23, R31 will contain the suffix 3 common, therefore denominator will be the common. Similarly, for star to delta conversion, R12. So here 1, 2, therefore R1 plus R2. Plus R1, R2 by the third one is R3. Similarly, R2, 3. So R2 plus R3 plus R2, R3 by R1. Third one is. Next R3, 1. So here R3 plus R1 plus R3, R1 by R2. So these are the formulas for remembrance purpose only. But in the actual problem, so you have to assume R1, R2, R3 values with a given figure and you have to convert accordingly. So thank you. This is about the Unit 1 formulas. We will see the Unit 2 formulas in the next video.